Hello friends, welcome to my new lecture on inequalities. In this video, I will be explaining you the applications of inequalities and how to solve inequalities. Let's understand first a few symbols which are used in inequalities. This symbol means less than, this symbol means less than or equal to, this symbol means greater than, this symbol means greater than or equal to. One simple logic you have to remember that this symbol, to the side which its mouth is open, we put the bigger number, and to the side which its mouth is shut, we put the smaller number. Combination of two symbols, this and this, gives you less than or equal to or greater than or equal to. Only these two symbols are used. Towards this side we put the bigger number, towards this side we put the smaller number. So to which side you have the bigger number, you place the symbol accordingly. For example, m is less than n. If this is written, then it could be read as m is less than n or n is greater than m. So it doesn't matter in which way you put the symbol, only the mouth, opening of this mouth matters. Now let's see types of intervals, and this is the most important part in the inequalities. You have to understand this thing very thoroughly. First is closed interval, means if an inequality is given, a is less than or equal to x is less than or equal to b, means that x is greater than a, but it can also be equal to a. X is less than b, but it can also be equal to b. Here the maximum value of x can be b, that is upper limit of the interval is b. X cannot exceed b. The minimum value of the variable is a. X cannot go less than a. If we want to write this in interval form, what do we write? We write a comma b, means the interval is from a to b, and if we use this square bracket, it means that the end points of the interval is included. That is, a to b is the interval, and square bracket means we have included a, square bracket means we have included b. Open bracket means when we are not including the end points. Here a is less than, x is less than b. X is greater than a, but it cannot be equal to a, means x can be anything greater than a, anything, even though slightest, but anything greater than a will be an acceptable value of x, but it cannot be equal to a. Similarly for b, x can be anything less than b. So here if we want to write it in the form of interval, we will write it, the interval is still the same, a to b, but here end points are not included, so we will use the open bracket. This bracket means the end points are not included. In this case, the maximum value of x is not defined, it does not exist, because anything less than b will be its, should be its maximum value. But what is just less than b? We cannot say, right? For example, if I say x is less than 2, then the maximum value of x is just less than 2, but we cannot write a number which is just less than 2. So maximum value does not exist, minimum value does not exist. Closed open means first value is included, second value is excluded. A is less than or equal to x is less than b, means here x can be equal to a but not equal to b, and it has to lie between the interval a to b. Here x max does not exist because the upper limit is not equal to x, but lower limit is can be equal to a, so x minimum is equal to a. Open closed means a is less than or x is less than or equal to b. Here we include the upper limit. In interval form we write x belongs to open interval a to b, closed interval, a excluded, b included. Maximum value of the interval x is b, it is achievable, but minimum value does not exist because x cannot be equal to a. Now let's see how these inequalities are represented on number line. This representation on number line is not important because nobody is going to ask you to represent an inequality on number line, but to find intersection of a number of inequalities, this method is very useful. So please understand it very carefully. Representation of interval means we draw a line. For example, if x lies between -4 to +6, what we do, we first draw the number line. We draw the number line and mark the relevant interval which we require. For here we need -4 to +6. So this part of the number line should include this interval -4 to 6. Now we draw a line over -4 to 6 to show that x has values between -4 to 6. Any number lying on this part of the number line will be your suitable answer for x. Now let's see how to include or exclude the endpoints. Representation of endpoints. If endpoints need to be included, we use a filled circle or dot. At the end of the line, we use a filled circle. For example, if x lies between -4 to 6 and x can be equal to -4 and it can be equal to 6 also, then what we do, we draw the number line, we draw the interval, and if -4, that is the lower end of the interval, is to be included, we put a filled circle over -4. If the upper limit of the interval is to be included, we put a filled circle over the upper limit, that is -4 a filled circle, 6 a filled circle, and the entire interval from -4 to 6. This representation represents the inequality x is greater than or equal to -4 is less than or equal to 6, or x belongs to closed interval -4 to 6 closed interval. Now the another case is if the endpoints are to be excluded, that is if the endpoints, that is -4 and 6 in this example, are to be excluded, then we use hollow circle or a hollow dot or arrows to show that this point is not included. X is approaching this number, but it is not equal to this number. For example, if x is greater than -4 but less than 6, we use the interval -4 to 6. At -4, since x cannot be equal to -4, we will not put a filled circle, but will put a hollow circle. And same at 6, since it is not equal to 6, we will put a hollow circle at 6 also. Or we can draw the interval -4 to 6, and to show that x is not equal to -4 but it is approaching -4, that x can be anything greater than -4 but not equal to -4. So we'll draw an arrow over the end where it is approaching -4 and where it is approaching 6. This shows that interval -4 to 6 is included and endpoints -4 and 6 are excluded. You have to remember one very important point, that sometimes plus infinity or minus infinity could be a part of your answer, that is x belongs to minus infinity to -2 or minus infinity to +5 or 5 to infinity, but we never put a closed bracket or equality sign at plus minus infinity because these numbers are very large or very small, they are not achievable. So you cannot say that x is equal to plus infinity, because if you are saying that x is equal to plus infinity, then you must be able to define it. Please remember, don't put closed bracket or equality sign at plus infinity or minus infinity. Let's do a question. First question is how to represent this inequality on number line, that is if we are given that x is greater than or equal to minus 2 is less than or equal to 4, then as I have already discussed that in the interval form it means x belongs to interval minus 2 to 4 both included, that is closed brackets. So on number line it means we have to draw the interval minus 2 to 4, and since both the endpoints minus 2 and 4 is included, we put a filled circle over here. Now if we have to draw minus 2 is less than x is less than or equal to 4, here 4 is included but minus 2 is excluded. So what we do, we use a open bracket over minus 2 to show that this number is not included, and we use a closed bracket over 4 to show that this endpoint is included. Remember, you first decide the interval, that is minus 2 to 4. Then you decide whether endpoints are to be included or excluded. Here the interval is minus 2 to 4. Minus 2 is to be excluded, so put an arrow. 4 is to be included, we put a filled circle. Now let's see one more example. If minus 2 is less than or equal to x is less than 4, then what? The interval is still the same, minus 2 to 4, but now we have to include minus 2. So we put a square bracket. Exclude 4, we put a open bracket. On the number line, we draw the interval minus 2 to 4. Since minus 2b is to be included in the interval, we put a filled circle. 4 is to be excluded, we put an arrow. Now minus 2 is less than x is less than 4 means neither of the endpoints are to be included in the interval. So x belongs to minus 2 to 4, the interval is same, but the endpoints are represented by open brackets to show that minus 2 and 4 is not included in the answer. To represent it on number line, we draw the interval minus 2 to 4, and since both the endpoints are excluded, we draw arrows at both the endpoints. Now we see that how to combine two different inequalities and get the required values of x for our answer. Suppose you are given that x is greater than or equal to 1 but less than or equal to 5, and x is greater than or equal to 4 but less than or equal to 10. Here and means you have to find values of x which satisfy inequality 1 as well as inequality 2. We all know that and means intersection of the values of x which satisfy both the inequalities. So first what we do, we draw these inequalities on the number line. The first inequality is x interval is, you always draw the interval first, 1 to 5. We draw the interval, we see that endpoint 1 is to be included, we draw a filled circle. We see that endpoint 5 is to be included, we draw a filled circle. So this represents inequality 1. Now see the second inequality, x belongs to the interval 4 to 10. We draw the interval 4 to 10, and since 4 is to be included, we put a filled circle. 10 is to be included, we put a filled circle over 10. Now we see that first inequality is satisfied in 1 to 5, means any x lying between this interval will satisfy first inequality, and any x lying between this interval 4 to 10 will satisfy the second inequality. We want x which satisfy both the inequalities simultaneously. So what we do, we take the part which is common to both the inequalities on the number line. We see that from 1 to 4 only inequality 1 is satisfied. 4 to 5 inequality 1 and inequality 2 both are satisfied, and 5 to 10 only inequality 2 is satisfied. So now we are ready to write down the answer. To write down the answer, you first write down the interval 4 to 5. x belongs to the interval to satisfy both the inequalities simultaneously. X belongs to the interval 4 to 5. We write down the interval 4 to 5. Now we see that whether endpoint 4 is to be included or not. To see that, you see x satisfies the 4 satisfies the first inequality, as well as it is also a part of the second inequality. So x is equal to 4 is a number which satisfies both the inequalities, and that's what we want. So 4 is part of the answer. We'll put a closed circle over here, closed bracket over here. And similarly, we go for 5, the other endpoint. We see that 5 is part of the first inequality, 5 is part of the second inequality as well. So it will be part of our answer. Therefore, the final answer is x belongs to 4 to 5 closed. Now let's discuss one more question. If 1 is less than x is less than or equal to 5, 4 is less than x is less than or equal to 9. Once again, we have to combine these two inequalities by AND. So we have to find the values of x which satisfy both the inequalities simultaneously. So what we do, we draw the number line, draw the first inequality 1 to 5. Interval is 1 to 5. 1 is excluded, 5 is included. We draw the second inequality 4 to 9. 4 is excluded, 9 is included. So accordingly you plot the arrows and dots. Now if we combine these two inequalities together, this interval numbers satisfy the first inequality and the numbers lying in this interval satisfy the second inequality. So we will take the common part in both the inequalities. We see that the interval is still same, 4 to 5. First write down the interval, then you go to check the endpoints, whether the endpoints are to be included or excluded. You see number 4 is a part of the first inequality. It is a part of the first inequality, so it can be included in first inequality. But when you go to the second inequality, you see that there is an arrow over here. Means this inequality is approaching 4, but it is not equal to 4. So 4 satisfies the first inequality but not the second inequality, and we need x which satisfy both the inequality. So what we say, that 4 has to be excluded because it does not satisfy both the inequalities. So we put a open bracket over 4. Now we go to 5. 5 is part of the first inequality, it satisfies the first inequality, and 5 is also satisfying the second inequality. So 5 can be part of our answer since it satisfies both the inequalities. So we will put a closed bracket over here. Let's do one more question. Remember that these numbers in inequalities does not matter. They are part of our answer, but main thing we need to concentrate is on these inequalities. Even though every inequality or the questions which I am discussing have the same numbers, but since the inequalities are changing, our answer is changing in every question. So you have to understand this very seriously, that how to solve these inequalities. Here first inequality says that x is greater than or equal to 1 but less than 5, and the second says x is greater than 4 but less than or equal to 9. First inequality, when we plot on the number line, we get 1 to 5, that is the interval, 1 included, 5 excluded. Next inequality says 4 to 9, the interval, 4 excluded, 9 included. Now when we try to see the common part, we see that 1 to 5 first inequality is satisfied, 4 to 9 second inequality is satisfied. So the common part is 4 to 5. The interval will be 4 to 5. You first write down the interval 4 to 5. Now we will decide whether 4, that is endpoints, are to be included or excluded, that is 4 or 5, which bracket to be used. Here you see 4 is part of the first inequality, but second inequality is not reaching 4, it is approaching 4, means 4 is not satisfying the second inequality. So 4 cannot be part of our answer because we need answers which satisfy both the inequalities. When we see 5, 5 satisfies the second inequality, but it does not satisfy the first inequality. We need numbers which satisfy both the inequalities, therefore 5 will also not be included in our answer. So the answer is 4 to 5, both brackets open, that is both the endpoints excluded. Let's discuss one more question. X is greater than 1 but less than 5, x is greater than 4 but less than 9, and we have to take intersection of these two inequalities. Here no equality is there. We first draw the number line, plot the numbers, then you find these numbers 1 to 5, first inequality, both excluded, interval is 1 to 5, endpoints excluded. Second inequality is 4 to 9, endpoints excluded. Now we find the intersection. We see that the intersection is still same, 4 to 5, but here 4 is satisfying the first inequality but not the second one. 5 is satisfying the second inequality but not the first one. So 4 not included in both the inequalities, so open bracket, it has to be excluded. 5 is not satisfying both the inequalities, so it has to be excluded. So our answer is open bracket 4 to 5. Let's do some questions for OR. We know that OR means union, means if x satisfies any one of these inequalities, then it will be a part of our answer. So let's plot the first inequality. X is greater than or equal to 1 but less than or equal to 5, means first interval is 1 to 5, both endpoints included. Second inequality is 4 to 10, both endpoints included. Now we take the intersection. 1 to 5, all the numbers satisfy first inequality, and 4 to 10, all the numbers satisfy second inequality. If a number satisfies any one or both the inequalities, it will be part of our answer. We have to take union. So the interval from here is 1 to 10. 1 to 10. We write the interval 1 to 10, and now let's see whether the endpoints are to be included or not. So 1 is to be included because 1 is satisfying the first inequality and 10 is satisfying the second inequality. So the entire interval including both the endpoints 1 to 10 is our answer. Let's discuss one more question. It is given that 1 is less than x is less than or equal to 5, or x is greater than 4 but less than or equal to 9. Means you have to find values of x which either satisfies the first inequality or satisfies the second inequality. Means x satisfying any one of these two inequalities or both the inequalities will be a part of your answer. So we plot the number line, plot the first inequality, interval is 1 to 5, 1 excluded, 5 included, second inequality 4 to 9, 4 excluded, 9 included. Now we see which all x we can take as our answer. 1 to 5 first inequality, 4 to 9 second inequality. From 1 to 4 first inequality is satisfied, 4 to 5 both are satisfied, and 5 to 9 second inequality is satisfied. So we see that 1 to 9 the entire interval is satisfying either one of these two or both the inequalities. So our answer will be 1 to 9. X belongs to interval 1 to 9, but here 1 is not part of the first inequality. X cannot be equal to 1. So we have to exclude 1 from our answer. So we'll put a open bracket over 1, and 9 is included in the second inequality. So we'll put a closed bracket over 9. Remember, if in between you see that some number is not included, then you have to use 2 or more intervals and then use intersection or union of these two intervals to report your answer. In this question, we will discuss if x is greater than or equal to 1 but less than 5, or x is greater than 4 but less than or equal to 9. We again plot the first inequality: 1 included, 5 excluded, 4 excluded, 9 included. Both the inequalities you have plotted on the number line. Now you see the inequality in the shaded region. 1 to 5 first inequality, 4 to 9 second inequality, 1 included, 9 included, 4 excluded, 5 excluded. But when we are writing the interval, we see that 1 to 4 first is satisfied, 4 to 5 both are satisfied, 5 to 9 the second inequality is satisfied. Though 4 is not satisfying the second inequality, but it is satisfying the first inequality. 5 is not satisfying the first inequality, but it is satisfying the second inequality. So 4 and 5 will be part of our answer. So the answer is 1 to 9, both endpoints included, 1 and 9 included. So closed bracket 1 to 9 is our answer. In this question, both the endpoints are excluded, that is x is greater than 1 and less than 5, or x is greater than 4 and less than 9. Now let's see what will be our answer. The first inequality is from 1 to 5, both excluded, 4 to 9, both excluded. So when we try to formulate the inequality for answer, we get x belongs to 1 to 5 for first inequality, 4 to 9 for second inequality. Therefore, we get the interval 1 to 9. This entire shaded portion is our interval. The end point 1 is not satisfying the first inequality, and it is not a part of the second inequality as well. So we see that since it is not satisfying any of the inequalities, it will not be included in our answer. Same thing goes for 9. We cannot include 9 in our answer because it is not satisfying any of the inequalities. Here x is approaching 9, but it is not equal to 9. So the answer will be open bracket 1 to 9. Now let's do a question where and, or, greater than, less than, all of the inequalities are combined, and let's see how to go about these type of questions. So here you are given that x is less than -2, or x is greater than or equal to 5, and x is less than or equal to 3, or 2 is less than or equal to x is less than or equal to 7. Here you are given in total 4 inequalities. You have to solve all of them and find the values of x which satisfies this condition. So we start plotting these number inequalities on the number line. The first inequality says x is less than -2, means you locate the number -2 and you draw the interval which satisfies this inequality. So x is less than -2 means anything less than -2 is our answer. So x belongs to -infinity to -2. This arrow means it is going on till -infinity. It is not ending at -10. And one more important thing you must remember, that you never put a closed bracket at the end of infinity, because infinity is a big number, very big number, but it is not measurable. If you say that your x can be equal to infinity, then you must be able to define it. If you are not able to define it, you cannot say what is infinity is, you cannot include it in your answer. So whether it is plus infinity or minus infinity, it will never be included in your answer. Remember this point very thoroughly. Strict. Infinity is not included in the answer. So the first inequality says that x is less than minus 2, that is minus infinity to minus 2. Second says x is greater than or equal to 5, means 5 to infinity. This number is going till infinity, 5 included, minus 2 excluded. This bracket means we have to first find the answer of these two inequalities. And now let's see this second bracket where we have got two more inequalities. We first solve these two inequalities, find the answer. We first solve these two inequalities, find the answer, and then we will take the intersection. So the third inequality says x is less than or equal to 3, means x is equal to 3 or anything less than 3, minus infinity to 3. Now second inequality says x is greater than or equal to 2 but less than or equal to 7, means 2 to 7 both included. Now let's see, there are too many inequalities involved over here. How to report the answer? So what we do, we will use different colors to represent the different inequalities. First two inequalities I have shaded in green color. Now the first part answer is x belongs to minus infinity to minus 2 and 5 to infinity. First part, any x belonging to minus infinity to minus 2 and 5 to infinity will be our answer. For the second inequality, anything satisfying minus infinity to 7 will be our answer, means anything from minus infinity to 7 will satisfy. You see the entire red portion is shaded in red, means anything lying between this will satisfy the second inequality, because we are combining these two inequalities by OR. So minus infinity to 3 satisfies the third inequality and 2 to 7 satisfies the fourth inequality. So minus infinity to 7 is satisfying the second bracket, 3 and 4, and minus infinity to minus 2 union 5 to infinity satisfies the first bracket. Now we have to take intersection of these two answers. So you see where this green and red zones are overlapping, that will be your answer. You have to just find the intersection. So you see minus infinity to minus 2, you have got both the inequalities red and green. So this will be your answer. So first interval, remember we will be writing the first the intervals only. We will discuss about the end points later on. So the first interval is minus infinity to minus 2, where all the four inequalities are, not all the four, both the brackets are satisfied. Now minus 2 to 2, not only inequality 3, 2 to 3, 3 and 4, 3 to 5, only 4. When we go to 5 to 7, we see that inequality 4 and 2 are satisfied. So we say that interval 5 to 7 will also be part of our answer. So we have got two intervals, minus infinity to minus 2 and 5 to 7. We will write these intervals, and now let's see which all end points to be included. We have got the intervals. Now only left is to decide whether the end points is to be included or excluded. As I have already told you, minus infinity or plus infinity can never be included in your answer. So you have to always use a open bracket at minus infinity or plus infinity. So we have put a open bracket at minus infinity. Let's come at minus 2. You see, minus 2 is a part of second bracket. This minus 2 satisfies the second bracket, but we need this number to satisfy the first bracket also. But we see that minus 2 is not satisfying the first inequality or any of these two inequalities. So we will say that minus 2 is to be excluded. So we will put a open bracket over here. So first interval is both open bracket minus infinity to minus 2, open bracket. The second interval, either your x lies over here or your x lies over here. So we have to combine these two intervals by union. So, we put a union and then we go to the interval 5 to 7. Now, see 5. 5 is part of the first two inequalities. So, it satisfies the first bracket, and 5 is also part of the second bracket. So, it satisfies the fourth inequality. So, we say that since it is satisfying both red and green inequalities, we say it will be part of our answer. So, we will put a closed bracket over 5. Same thing goes for 7. 7 satisfies the green inequality and as well as the red inequality. So, our answer is close bracket 5 to 7. So, the final answer is x belonging to open bracket minus infinity to minus 2 union closed bracket 5 to 7 is our answer. Anything lying in this interval will satisfy this entire inequality. So, this completes the inequality chapter. Thank you very much for watching. Please do subscribe to my channel YLC, that is your learning curve. Please remember, practice makes a man perfect and there is no substitute for hard work. Thank you very much.